Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a triangular prism having the base edge 40 millimeter and axis length it is equal to 65 millimeter. Now this triangular prism happens to be resting onto the horizontal plane on one of its rectangular faces with axis of this prism being parallel to the vertical plane. So here we have got this triangular prism which is having two faces A, B, C, which is the front face, and A1, B1, C1 happens to be the rear face of this triangular prism. Now this triangular prism, it is resting on its rectangular face, that is A, B, B1 and A1 onto the horizontal plane. Now we have got an auxiliary inclined plane. It is going to cut this triangular prism and this AIP will be inclined at an angle of 45 degree with respect to the horizontal plane, and the cutting plane, it intersects the axis of this triangular prism at a distance of 25 millimeter from one end of the prism. So here we can see the axis point is going to lie somewhere here, that is point O and point O1. So onto this axis line which is going to join the two faces of this triangular prism, now at a distance of 25 millimeter from one of the faces. So this face happens to be face ABC. So along the axis 25 millimeter away from the face ABC, now an auxiliary inclined plane which happens to be inclined at an angle of 45 degree with respect to the horizontal plane, it is going to intersect the axis at a distance of 25 millimeter from the face ABC. Now this way, this is the sectioned view which will be available. So this triangular prism will be cut at 3 points 1, 2 and 3 over here. Now with this information, we are required to draw the front view projections, the sectional top view projections, the sectional side view projections, and the true shape of the cut section of this triangular prism. So now since this prism happens to be resting onto the ground on one of its rectangular faces, and the two faces of this prism A, B, C and A1, B1, C1, so these two faces, they happen to be parallel to the profile plane. So to begin with, the first projections we are going to obtain corresponding to this triangular prism will be the left hand side projections of this prism. So this way, the left hand side projections of the prism obtained onto the profile plane have to be derived first of all. Now let us proceed with the evaluation of the left hand side view projections of this triangular prism, and these left hand side view projections will be obtained on right hand side corresponding to the reference line x1 y1 over here. So here we are going to draw the front view of this triangular prism. Here we are going to obtain the top view projections of this triangular prism, and first of all we are going to obtain the left hand side view projections of this triangular prism. Now as the observer is going to look at this triangular prism from the left hand side, so we will observe that points A and A1, they are going to coincide onto the profile plane. Points B and B1, they are going to coincide onto the profile plane. Points C and C1, they will also be coinciding onto the profile plane. So this equilateral triangular face having edge of the base equal to 40 millimeter will be obtained into the profile plane projection over here. So here we can see we have obtained an equilateral triangular projections onto the profile plane corresponding to this triangular prism. Now here we have got the edge A and A1. So the projections corresponding to the edge A and A1 will be obtained as A double dash and A1 double dash. Similarly, projections corresponding to the points B and B1, they will be obtained as B double dash and B1 double dash over here. And similarly, the projections corresponding to the points C and C1 will be obtained as C double dash and C1 double dash into the profile plane projection view over here. And the edge length corresponding to this equilateral triangle, it happens to be 40 millimeter. Now having obtained the side view projections of this triangular prism, now we need to evaluate the location of the axis of this particular prism. So in order to locate the axis of this triangular prism, now we have drawn the perpendicular bisectors from each of the corners of this particular triangular projection onto the opposite edge over here. So from C dash, we have drawn a perpendicular bisector of the edge A dash, B dash. Similarly, from the point B double dash, now we have drawn a perpendicular bisector of the edge A double dash, C double dash over here. Similarly, from the point A double dash, so we have obtained the perpendicular bisector of the edge B double dash, C double dash. So wherever these three projectors, they are going to intersect with each other, we obtain the axis points corresponding to the two faces. So onto the face ABC, the axis point O double dash will be lying. Onto the rear face of this triangular prism, that is A1, B1 and C1. So point O1 double dash corresponding to this axis will be lying over here. Now we have obtained the height of this triangular prism through this construction into the profile view projection over here. So once we know the height of this triangular prism, now from C double dash and C1 double dash, now a projector line will be extended into the front view projection view. Similarly, the axis line we have also extended into the front view projection view, and from the points A double dash, A1 double dash, B double dash and B1 double dash, again another projector line we have drawn which is going to coincide with the XY reference line into the elevation projection view. Now we have been provided with the information that the length of the axis happens to be 65 millimeter. That is the length of this triangular prism or the axis, that is the distance between C and C1, distance between A and A1, distance between B and B1 should be equal to 65 millimeter. Now once we have drawn projectors through all the points corresponding to this triangular prism into the front view projection area, now we will be drawing two vertical projector lines over here which will be having the distance between these two projectors as 65 millimeter, which happens to be the length of the axis of the prism, or this happens to be the length of the prism over here. So this way the front view projections of this prism, they have been obtained. So let us obtain the different points. So since the left face of this triangular prism comprises of the ends A, B, C, and the right face of this triangular prism comprises of the points A1, B1 and C1. So corresponding to the left face, the front view projections corresponding to the point C will be obtained as C dash. Similarly, corresponding to the right side face, the projections corresponding to the point C1 double dash will be obtained as C1 dash, and the distance between C dash and C1 dash will be equal to 65 millimeter. Similarly, the next point which is available in the front view is axis point. So O dash is the axis point onto the face ABC. O1 dash, it is the axis point which is going to lie on the face A1, B1, C1. Next we have got corresponding to the base, we have got A dash, B dash points coinciding with each other in the front view projections corresponding to the points A and B. Similarly, A1 dash and B1 dash points, they are going to coincide with each other onto the right hand side face of this particular triangular prism over here. That is, if you are going to look from this side, A dash and B dash, they will be coinciding with each other. As we are going to look from this side, that is the front view projections, A1 and B1, they are also going to coincide onto the XY reference line. So the front view projections as well as the side view projections of this triangular prism, they have been obtained. Now let us proceed to evaluate the top view projections of this prism. So here we have got this transfer line. So using this transfer line, now the depth along the side view, it will be transferred onto the top view projections over here. So now from points B double dash and B1 double dash, now we have drawn this projector onto the transfer line. Now through this transfer line, points B and B1, they will be transferred onto the top view projection. So this point will happen to be point B, whereas this point will happen to be point B1. Next we have got these 4 points over here, that is corresponding to point C double dash and C1 double dash and O double dash and O1 double dash. Now these 4 points, they have coincided onto the side view projection. Now once we draw a vertical projector onto the transfer line, and now through the transfer line we have transferred these 4 points onto the top view projections over here. So the point O corresponding to this point O double dash will be located over here. Similarly, point O1 corresponding to this point O1 double dash, it will be located over here. This is the axis. So axis point and point C, they have coincided with each other in the top view projections over here. Similarly, the point C double dash, it will be projected onto the top view projections into this position, that is this point. Similarly, point C1 double dash, it will be projected onto the top view projections over here, that is corresponding to C1 dash. This point C1 has been obtained. Corresponding to C dash, this point C has been obtained. And finally we have got the point A double dash and A1 double dash. So from these 2 points we have drawn a vertical projector line, and now we have extended this onto the transfer line, and then through the transfer line we have managed to transfer these points into the top view projection. So point A will lie onto this face, that is point A will be located over here. Similarly, point A1 will be located over here. So now the front view projections, the top view projections and the side view projections corresponding to this triangular prism resting on one of its rectangular faces onto the horizontal plane have been obtained. Now we have been provided with the information that there is a cutting plane, that is auxiliary inclined plane, which is inclined with respect to horizontal plane at an angle of 45 degree. Now this auxiliary inclined plane, it is going to pass through this axis. Now where does this axis lie in the front view? O dash point lies here, O1 dash point lies here. Now we have measured this distance of 25 millimeter from the face ABC. So from the face ABC alongside this axis, so axis is going to lie here. So onto this axis, if we move 25 millimeter away from this face ABC, now the cutting plane will be passing through the axis inclined at an angle of 45 degree with respect to the horizontal plane. So it is this point onto the axis which is located at a distance of, you can check, 25 millimeter from the face ABC over here. So from the face ABC, we have got this axis, and 25 millimeter from this face, we have got an auxiliary inclined plane passing through the axis. It is cutting the axis at this point over here. And this auxiliary inclined plane happens to be inclined at an angle of 45 degree with respect to the horizontal plane. Now, we have observed that this portion has been cut by this auxiliary inclined plane. So this portion has to be removed. So this portion of the triangular prism will be removed or it will be thrown away. Now we are left with this remainder portion of the triangular prism. So this portion of the triangular prism is left behind after the cutting action by this auxiliary inclined plane, which is inclined at an angle of 45 degree. Now we obtain that there are 2 points you can check. Point 1 alongside AA1, point 2 alongside projection line BB1, and point 3 which is lying along the edge CC1. So at these 3 points, the cutting plane has intersected these longer edges of this triangular prism. So these are the longer edges, AA1, BB1 and CC1. So AA1 has been intersected by the cutting plane at the point 1. BB1 has been cut by this cutting plane at the point number 2. And CC1 longer edge of this triangular prism has been cut by this cutting plane at the point 3. So we have got front view projections of these 3 points as 1 dash, 2 dash and 3 dash over here. Now these 3 points we need to obtain in the top view projections over here. So we can see that if we draw the vertical projectors through these 2 points 1 dash and 2 dash onto the top view projection, so we obtain this projector line. Similarly, when we draw a vertical projector line emerging from the point 3 dash onto the top view projections, so this projector has been obtained over here. Now we know that the longer edge AA1, it has been cut by the cutting plane at the point 1, while the longer edge BB1 has been cut by the cutting plane at the point 2. So the top view projections corresponding to these 2 points we have obtained over here. Point 1, it lies alongside this longer edge AA1. Point 2 lies alongside this longer edge BB1. Similarly, when we draw the projector from point 3 dash, so this projector will be intersecting with the top view projections corresponding to the longer edge CC1 at this point. So this way, point 1, point 2 and point 3 projections, they have been obtained in the top view projections over here corresponding to this cut section which happens to be inclined with respect to the horizontal plane. So this is the cut section of the solid which is inclined with respect to the horizontal plane at an angle of 45 degree. Now we have obtained this rectangular portion of the prism which will be visible to the observer as the observer is going to look at this prism from the top view. Similarly, if we join the corners 1, 2 and 3 over here corresponding to this section surface, so we observe that this is going to be our sectioned top view of the solid over here. 1, 2 and 3 triangular sectioned view, or the apparent shape of the cut section we are going to obtain in the top view projection. So that is why the sectioning has been added over here. And another thing, corresponding to this edge, you can check it out over here, 3 to C1. So this portion of the longer edge which is left out, so this portion will be visible to the observer. That is, out of the total longer edge C and C1, so the portion C and 3 has been removed. So the remainder portion of this longer edge on the top side of this triangular prism 3C1 will also be visible to the observer. So we have joined 3C1 over here. So this completes the top view projection as well as the front view projection corresponding to this triangular prism. And here we have obtained the sectional top view for the cut section which we can observe over here, which is appearing as 1 dash, 2 dash, 3 dash into the front view projection. And now why this is the apparent shape? Because this cut section happens to be inclined to the horizontal plane. So into the top view projections we are not able to obtain the true shape projections of this cut solid. So we are able to obtain the apparent view projections in the section top view. Now let us obtain the section side view corresponding to this solid. Now when the observer is going to look at the solid from the left hand side, so now we can check points A double dash, A1 double dash and 1 double dash. They will be coinciding with each other. Similarly, points B double dash, B1 double dash and 2 double dash over here, they will also be coinciding with each other in the side view projection. Similarly, the points C double dash, C1 double dash and 3 double dash over here, they will also be coinciding with each other. That is, now we have to superimpose the points 1 double dash onto A double dash and A1 double dash. The point 2 double dash will be lying alongside the points B double dash and B1 double dash, and similarly the point 3 double dash will be coinciding with the points C double dash and C1 double dash. So this way the 3 points corresponding to this cut section, that is 1 double dash, 2 double dash and 3 double dash, they have been obtained into the profile view projections over here. Now we have got the section side view as 1 double dash, 2 double dash and 3 double dash. So which is once again the apparent shape projections corresponding to the side view of this cut section over here. This is going to be the section side view, which is once again an apparent shape projections corresponding to this cut section. Why these projections they happen to be apparent shape projections? Because this cut section is also inclined to the profile plane. So onto the profile plane we will not be able to obtain the true shape projections corresponding to this cut section 1, 2 and 3. Now the question arises, how do we obtain the true shape projections of this cut section? So we will be able to obtain the true shape projections of this cut section only when we are able to draw an auxiliary inclined plane x2, y2 which happens to be parallel to this cut section over here or the cutting plane over here. So this is the cut section 1 dash, 2 dash and 3 dash, or this is the cutting plane, right? Now parallel to this cutting plane or the cut section we have drawn an auxiliary inclined plane x2, y2 such that this AIP x2, y2 it happens to be parallel to this cut section also. Now since this cut section is parallel to this AVP x2, y2, so the projections of these 3 points 1 dash, 2 dash and 3 dash onto the auxiliary inclined plane will provide us with the true shape projections of this cut section into the auxiliary top view, because we know that onto an auxiliary inclined plane auxiliary top view projections they have to be derived. Now from 1 dash, 2 dash and 3 dash we have drawn perpendicular projectors onto this auxiliary inclined plane x2, y2. Now corresponding to the points 1 dash and 2 dash, auxiliary plan projections of the points 1 and 2 will be located alongside this projector line. Similarly corresponding to the point 3 dash, so the auxiliary plan projections corresponding to the point 3 will be obtained alongside this projection line. Now let us obtain the auxiliary plan projections corresponding to the 3 points 1, 2 and 3. So from point 1 you can check, here we have got point 1, here we have got point 2. Now we are going to measure the distances of the points 1 and 2. This is the distance of point 1 from the XY reference line. This is the distance of the point 2 from the XY reference line, and this is the distance of the point 3 from the XY reference line. Now corresponding to the point 3 dash, so this is our projector line. So onto this projector line, if we measure this distance, that is the distance of point 3 from the XY reference line, right? So if we measure this distance and plot it over here ahead of the AIP x2, y2, so this distance of 0.31 from the auxiliary inclined plane x2 y2, it will be same as distance of point 3 from the xy reference line into the plan projection view over here. Similarly, this is the distance of point 2 in the plan projection view from the xy reference line. So the same distance we are going to mark onto the projector line which we have drawn through the point 2 dash, and this distance will be marked ahead of the plane. So this distance provides us with the location of the point 21 over here. And finally, here we have the point 1 over here. Now we are going to measure the distance of the point 1 from the xy reference line and plot the same distance onto the projector line drawn through the point 1 dash over here. So onto this projector ahead of the plane, same distance ahead of the auxiliary inclined plane x2 y2 we are going to plot over here. So this way, this distance of 0.11 from AIP x2 y2, this will be equal to the distance of 0.1 from the xy reference line into this apparent plan projection view over here. So now we have obtained 3 points 1, 1, 2, 1 and 3, 1 over here. So if we join all of these 3 points, now we are able to obtain the true shape projections corresponding to this cut section which appears as 1 dash, 2 dash and 3 dash into the elevation view projections over here. So since this cut section happens to be parallel to this auxiliary inclined plane x2 y2, so onto this auxiliary inclined plane, that is into the auxiliary plan projection view, we are able to obtain the true shape projections of this triangular prism which has been cut by an auxiliary inclined plane which happens to be inclined with respect to the horizontal plane at an angle of 45 degree. So this way we have been able to obtain the front view projections, the top view projections, the profile view projections as well as the true shape projections corresponding to this truncated triangular prism which has been cut by an auxiliary inclined plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure to develop the front view, top view and the section side view projections of the truncated triangular prism, besides evaluating the true shape of the cut section of this truncated triangular prism over here. So we'll be continuing with further discussion regarding few more illustrative cases of sections of the solids in the coming lectures. So thank you very much. Thanks a lot.